This one's going to be super short. Let's go for under 5 minutes. Okay, so we've talked about waves in the open ocean. Now we have to talk about, for the rest of the chapter, waves coming into shore. We talked about seas. We talked about swell. Now we're going to talk about surf. And I guess first we should talk about the surf zone. The surf zone is where breaking waves basically hit the near shore. I wrote near shore like it's 2 words, but it's near shore. And they begin to change. And we're going to talk about how they change in great detail in the next couple slides. But there's a word that's in the book that you should probably know, which is shoaling water. Shoaling water is an area where the water becomes more shallow. It's like the slope of the beach. And you begin to see the kind of white water and those lines of wave crests coming in. So what happens? Okay, so what happens basically is deep water waves hit shoaling water. And when that shoaling water's depth is less than 1/2 their wavelength, they become transitional waves. And they begin to, quote unquote, feel the bottom. This is an important concept that you'll probably need to regurgitate on quizzes and tests. So what happens then? A bunch of things begin to happen to them. And eventually, as they enter shallow water, when the depth is like 1/20th wavelength, they become a shallow water wave. So let's talk about this. So what happens when a deep water wave finally becomes a shallow water wave? And there are 4 things on this slide that you must know. And they're right here. I can start drawing. There are these 4. And the first thing that happens is the wave speed decreases. Again, because it's feeling the bottom. The wave is dragging, there's friction. Because that wave speed is decreasing fastest in the front of the wave as it approaches shore, the back of the wave is still moving kind of a little bit faster and it begins to catch up. So wavelength decreases. When wavelength decreases, the energy is still there. It has to go somewhere, so wave height increases. So basically you're taking a wave that was like this, and you're decreasing. Oh, I might make that obvious enough. Okay, so you're shortening the wavelength, but you're increasing the wave height. Because you're changing the height and the length, you're increasing steepness. So 2 things increase, 2 things decrease, and you need to know which. This is a diagram that's in your book. I wish I remember the number. I don't. This is basically the same idea. So the wave base is here. Oh, go back. So we have the wave base right here. And so anything that's forward of this area is, quote, feeling the bottom, okay? And that means that there's drag. So if you notice these pink areas, I'll draw them in pink too, right in here. Notice that the bottom part of the wave is kind of falling behind. That's because it's dragging, so the friction is slowing down the wave. So the waves slow down. Then the wavelength decreases. Notice the wavelength from the back here to up here. Wavelength has decreased. Wave height has increased. And eventually the waves break because they reach critical steepness. So those are all things that you need to know. Surf comes in 2 types. There's the surf we get from swell. Swell, when it hits the beach, is still called surf. And that's a nice surf. I say this as a former surfer. We like swell. Swell that hits the beach and becomes surf has very uniform breakers that have nice clean waves. The waves break close to shore. They're rideable. And things like that. When you get surf that, again, still waves in the near shore zone that are generated by a storm on site, generated by local winds, it's going to look like seas still. It's going to be choppy, high energy. You're going to find white caps. And you can find both types of surf here. So just because it's looks like seas or looks like swell, if it's in the near shore zone, it's still surf. The next part of this slide we've sort of talked about, but I'm going to talk about that feeling the bottom thing more on this slide. Oh, no, I'm not. On this slide. Why does a wave break? This is an important idea. And one that you need to be able to explain. Wink, wink. So the waves feel the bottom. There's friction at the bottom. And the bottom of the wave is slowing down even more than the top of the wave. Though the top of the wave slows down too. In addition to that, we also know that wave steepness is increasing because the wavelength is shortening and the wave height is increasing. What basically happens is the top of the wave moves faster than the bottom of the wave, which causes wave steepness to be so big that the wave topples over. And that's basically how we get a breaker. And you need to be able to explain that idea. We're going to talk about the 3 types of breakers: spilling, plunging, and surging. There are 2 factors, really, when we're talking about these breakers that you need to know in order to compare and contrast them. How much wave energy and the slope of the seafloor. So spilling breakers have a low amount of energy, okay? Not a lot of energy associated with them. And they're what we get around here mostly because they're associated, not drawing. Let's try this again. They're associated with a very gentle slope. So the waves come in on a very gentle slope and you get a spilling breaker. One of the questions that we see over and over again, especially in Ocean Bowl, but even here, is which one is better for surfing? If the point of surfing is to get as long a ride as possible, then spilling breakers are the way to go because they have low energy and they're expended over a long distance. So the ride, the distance that you can travel on the wave, the time period you can spend on the wave is much longer. So spilling breakers are better for a long ride. They also tend to be foamy and there's less of an air pocket. When you see the big surfing movies, they usually show people on plunging breakers. Now, plunging breakers are moderate in both ways. They're moderate slope. So if I were to draw this, dear God, I hope this works this time. It's a little bit steeper, and there's a little more energy. And one of the key factors is this air pocket. You watch old goofy movies and they call it the tube, okay? But basically plunging breakers have to have an air pocket. The surfers who are into that sort of more extreme surfing, like the ones in the movie we were watching, Mavericks, they tend to seek out this type of wave. So sometimes if you're asking what's the best wave for surfing, being in the barrel, in the tube, is one way to kind of classify that. But remember, this is a shorter ride because we have more energy and a shorter distance. It's a shorter ride than in the spilling breaker. The last one we have are surging breakers. We don't see that too much around here. We can get, most of our waves are spilling breakers. We get a big wave on a sandbar, we can get plunging breakers. But surging breakers have the steepest floor. And, I hope that's obviously steep. And basically they look like that. Basically the wave just hits the seawall or a cliff or something like that. They have a very, very short ride. And very high energy still, hasn't been diffused across a large distance. So hopefully you can explain these 3 in terms of their slope and the amount of energy they have. I had to put this quote in here. This is literally a direct quote from the book. Surfing is like balancing on a gravity-operated water sled. No joke, that's literally a water sled, whatever. Surfing's kind of mentioned a bunch in this book and a little bit in the movie, but it's an interesting thing and kind of a big deal around here. And we're going to stop there.